Okay, let's start. Hi again. So my name is Ivan Krutov. I'm from a parallel universe. I'm not a front-end engineer, not a front-end developer. However, I'm doing something really related to front-end development. I'm doing browser automation infrastructure, and because of that, today I will be showing you how to organize a truly uniform browser automation infrastructure. So a few words about me. Being software developer during the last decade, my main experience is related to Java and Golang programming languages. My main activities during the last already 7 years are called with a buzzword DevOps. That means that I'm creating and maintaining various infrastructure. And one of the biggest projects I'm working on is a big Selenium cluster. So how big is this cluster? Compared to a typical Selenium Grid, having 50 browsers and executing 10,000 browser sessions per day, my cluster has more than 5,000 browsers running in parallel and executing more than 2.5 million browser sessions per day. These browsers are distributed across 5 data centers. The average load on the cluster is about 4,000 requests per second. The traffic is more than 2 gigabits per second. And this cluster is certainly working all the time. This cluster has all popular browsers and platforms, including last 10 versions of Firefox, Chrome, Opera, all versions of Internet Explorer, Microsoft Edge, Android emulators running on real hardware servers, iOS simulators running on Mac Minis, and for some teams, we also have real devices, phones and tablet PCs connected to the same cluster. Also, some of you could have heard about or could be using one of the tools we are working on, including Selenoid, which is an open source implementation of Selenium protocol running your browsers and Android emulators in isolated Docker containers. There is also Moon, an implementation of Selenium for Kubernetes and OpenShift cluster. And we also have a new tool, a new product called Moon Cloud. That's the case when we deploy and maintain a dedicated Moon cluster for your team in a cloud platform. So if you have any questions related to one of these tools, please don't hesitate to ask me during the QA session, okay? So right now there will be some motivation about why we created the tools I will be showing you today. And then in a few minutes, I will start showing things, like I will start the workshop. So I think most of you would agree that testing is one of the most important parts of software development cycle. And if you are developing the web application, the only way to check that your application is working correctly on the user side is running this web application in a real browser. So that's the only way to check this. However, running any end-to-end tests, including a browser test, seems to be an expensive stuff. First of all, browser automation and tests in browsers are usually slower than other types of tests, for example, unit tests. Also, such types of tests require more time for preparing a tested environment. For example, you may need to start a virtual machine or a container with a tested copy of your production web application. Also, such tests require more effort and experience to maintain them. For example, in case of tests in browsers, you constantly need to maintain in accurate state so-called CSS selectors. That means expressions allowing you to find elements on the web page. Also, computing resources for end-to-end tests are usually more expensive than for other types of tests. For example, if you need to run tests in browsers, usually one browser running in parallel requires at least one CPU core and 1 or 2 gigabytes of memory. So having these two facts in place, that first of all, tests in browsers are really, really important. And secondly, that such type of tests is expensive, we need to make sure that our browser automation infrastructure is, first of all, reliable, should be easy to deploy, easy to scale. That means you should be able to easily add more computing resources to this browser automation infrastructure. This infrastructure should uh, consume computing resources. That means its CPUs, memory, disk, and so on, in economical way. It should be uniform. That means you should be able to deploy just the same solution to a big cluster as well as to your local machine where you are actually developing and debugging your tests. And this browser automation infrastructure should also support all actually popular browser automation technologies. So first of all, let's remember that currently the worldwide standard of browser automation is called Selenium, and the reference implementation of this Selenium protocol is called Selenium Grid. So I think most of you have heard about Selenium Grid. And currently, the stable Selenium Grid version is version 3. And while Selenium developers are already for 2 years developing the next stable version, Selenium Grid version 4, I'm continuing to I'm continuing to say during my talks on the conferences that Selenium Grid is not a reliable solution for running your tests in browsers. This is because if you install Selenium Grid and try to run the tests in Selenium Grid, sooner or later you will face one of the following issues. So, for example, this one, trying to run your Selenium tests in parallel in several browser windows will sooner or later lead to flaky tests. This is because usually on the web pages there are elements that, how do I say, that depend on whether your browser window is in focus or not. So, for example, on this picture, there is a green button which is not green when your browser window doesn't have focus. And so far as in modern operating systems, only one browser window can have a focus. Depending on whether your window has focus or not, your test will pass or fail. The second issue you may encounter is that one day your Selenium conveyor could completely stop executing your test, could completely stop loading the pages. For example, after a long working day, you could just accidentally open the settings in the browser, do a few clicks. For example, you could type an incorrect proxy server address, and the next day you come to the office and you see that your pages don't load. So a few accidental clicks in browser settings could completely stop the execution of your tests in browsers. So sooner or later, you will also understand that it's impossible to have several versions of the same browser installed on the same machine with Selenium Grid. This is how package managers in the modern operating systems usually work. So for example, having Firefox 82 installed on the machine with Selenium Grid, when you try to update it, when you try to install Firefox 83, the previous version is automatically removed. So, and the deeper investigation of all these issues leads to a conclusion that the majority of such issues could be are just caused by the lack of isolation between browser processes. And there are several ways of providing correct isolation between browser processes. For example, you can certainly launch a virtual machine with only one browser running inside. However, using standard virtual machines is slow and resources consuming. And this is where containers come into play. Containers, like Docker containers, provide lightweight and very efficient isolation between browser processes. And usually such containers, such images for such containers have inside, first of all, the X server. That means a graphical application showing you, allowing you to run applications in Windows. Also the WebDriver, that's a standalone binary translating Selenium test commands to browser-specific commands. Also, you have there certainly browser and some other stuff like fonts and encoding, so everything you need to correctly render the web pages in browser. Usually, in case of using containers, for every test, you need to start a separate container, and this container is usually removed when your test finishes working. So if we now just take a look again at a currently stable version of Selenium Grid version 3, we can state that this version simply can't use containers for running the tests. So currently, there are several solutions allowing you to run tests in browsers in containers. The first one is called Selenium. That's an open source solution, which is a set of extensions for Selenium Grid, and it allows to run browsers in containers. Then there is a Selenoid. This is our implementation of Selenium protocol, which is a completely new implementation from scratch using the Golang as an implementation language. And the third one is Moon, which is using Kubernetes cluster. So the first two implementations are using regular Docker, and Moon is using Kubernetes cluster. This is what we will be talking about today. So if we now talk about the ease of deployment, here is a picture that I took from the official documentation of Selenium Grid 4, and that's an architecture of how Selenium Grid version 4 will look like. And you can see that here, instead of two components, hub and node, that we have in Selenium Grid version 3, here we have six separate components. And this is not how a truly simple, truly like easy to deploy solution should look like. So don't do like this. A truly simple, a truly easy to deploy solution should usually be a single box also running in a container. And this box should be using a container API to launch containers with browsers. So for example, when you test requests a browser from this Selenium API, it just does a request to the container API and launches a container with a requested browser version. And then your tests start executing. When your test finishes, this container should be automatically removed, thus leaving your operating system in the same state it was before actually launching the test. So currently, there are two the most popular container execution environments. That means container APIs that we can use. The first one is called Docker. I think most of you should be aware of Docker. And the second one is called Kubernetes. And there are several derived products like Red Hat OpenShift, which are compatible, which are using the same principles as Kubernetes. So just to clarify the difference between the standard Docker and the Kubernetes, let me show you this picture. Standard Docker, as you could see, I think, can only run containers on only one host, only one hardware server, or only one virtual machine. And the main difference between Kubernetes and the standard Docker is that Kubernetes can automatically distribute containers on top of an unlimited set of hosts or virtual machines. So it can launch containers and can remove containers, various hosts. And what's the most important, it can automatically analyze whether there are sufficient CPUs and memory on a concrete host to launch a new container. So that's the main advantage. Okay, so that was a brief introduction what we will be talking about today. And now I will start showing you things. So here is the program, what I will be showing you today. First of all, let me just, how to say, let me just tell about the prerequisites, because in the emails you should have received, there were two prerequisites of what we will need today to use to do the same thing I will be doing. So first of all, you will need a running Kubernetes cluster. Usually you could install it with the MiniCube tool. So I will quickly show today how to do this. That's the first thing. The second one, you will need just a regular Git, just to clone some repositories. Our today's workshop will consist of two parts. We will prepare a video recording. So all this video will be published to YouTube, so we could just try everything later if something doesn't work today. The first part will be about delivering the local browser automation infrastructure. I will just show how to deploy Moon locally, or what features do we have, and so on and so forth. And during this part, you can try to repeat everything I will be doing. So as I said, if something doesn't work, just don't worry, you will be able to see the video again. And the second part, I will be talking about the remote browser automation infrastructure. That means I will be showing how to deploy a cluster allowing you to run Selenium, Playwright, and Puppeteer tests in the same cluster, and I will be doing this in a cloud platform. So during the second part, you are just expected to just watching what's happening, and probably you will also use this video to repeat all the steps later. So after every part, we will have a Q&A section. And after the first part, we will also have a 5-minute break. So every part will last approximately 45 minutes, something like this. So during the break, you will be able to prepare a coffee, so everything you wish. Okay, and the last thing before I start, I will be reading all the questions from the Discord channel. So there is a Discord channel which should be called February 3 Uniform Browser Automation Infrastructure. So just please contact conference organizers if you have any issues joining this channel. Okay. Okay, so now let's start doing things. This was everything related to Moon motivation. The first thing I will be showing you is how to install Moon locally, because I will be showing everything related to Moon, and we'll be doing this installation on a MiniCube cluster. So the first thing we will need to do, we will need to start a Kubernetes cluster with MiniCube tool. So let me show you how to do this. Let me show you, let me open a separate terminal. In order to start a Kubernetes cluster, we just need to have the following command on in our operating system, which is called a MiniCube. If you don't have this command yet, you can easily download the respective executable from the GitHub. So we go to the github.com, Kubernetes MiniCube, and we go to the releases page. So that's the Kubernetes MiniCube. Let me send this link. MiniCube download. So we just go to a respective repository on the GitHub. We take a latest release, and here, just let me increase a bit the font. And here in the assets section, we have binaries for different platforms. So for example, for Mac, there is MiniCube, Darwin, AMD64. For Windows, there should be an installer. For Linux, there is MiniCube Linux, AMD64. So we just need to download this file and then execute it. So I just did this step. I just already have this command in my operating system, but just let me show you an example command how downloading of this file could look like. So I just copy the URL. I just switch to my console, and I could just do stuff like this: usl local bin MiniCube, and then I just paste the URL to MiniCube here. That's the only thing I need to do. And well, after downloading the respective file, I need to just add execution permissions to this file, bin MiniCube. Okay. So after doing this step, you will have a MiniCube tool on your machine, and we are now ready to start a Kubernetes cluster with MiniCube on your machine. To this, we need to issue a very simple command, MiniCube start. So this command will do everything automatically. It will download an image from with Kubernetes, and it will automatically start this image on your local machine. So after several minutes, you will have a Kubernetes cluster running on your local machine. Here, it's saying restarting existing Docker container just because I have already executed this MiniCube startup command, and I already have an image on my machine. So it will just start an image and just configure the tools on my machine to work with this cluster. So while we are waiting for the cluster to start, let me now explain what we will be doing next. The next thing we will be doing, we will be installing Moon to our local machine. To do this, we will need we will need to download so-called YAML manifest. That means machine-readable files that Kubernetes is using to start applications. So to download these files, we'll just need to go to GitHub, github/aircube/moon deploy. Let me send an URL here. So let me send an URL. There's a question which one we should download for macOS Intel related to MiniCube. You should download the version for macOS. This is called Darwin AMD 64. Darwin AMD 64. Okay. So here is a URL with Moon installation manifests. What we need to do, we need to clone this repository. So we just go to GitHub, we just clone this repository as usually with git clone. Just let me open one more terminal. So I'm just going to my directory. No, there's no such file. And I'm just cloning this repository just using git clone. It should be rather fast because we are just cloning the text files. Failed to watch. Something strange here. Okay. Let me, while we're waiting for this Kubernetes cluster to start, let me show you what we have here in Moon deploy. Moon deploy directory. Yeah, kubectl is now configured to use MiniCube. So we now have a ready to use cluster with Kubernetes. And once I'll explain you what will be happening right now, we will start running Moon. So here in Moon deploy repository, we have several files with a YAML extension. Every such file, so let me show you, for example, the file we will be using, which is called Moon local. That's a regular YAML file containing entities that Kubernetes will be just using to deploy the application. There is stuff like services, stuff like, for example, deployment. There's information about the images we will be downloading. There's information about network ports we will be exposing, and so on and so forth. So that's a fully automated machine readable instructions on how to deploy the application. By the way, let me share one more link here. Let me share one more link. If you're stuck with the installation, we have the documentation describing all the steps in the detail. So you could just start copy pasting all the commands. So we have the documentation here, and you can just copy paste. This is how to install Moon with MiniCube. Basically, what we did already, we cloned this repository from the GitHub. We changed the directory to the repository, and we will now, in fact, need to run only one command like this. This command will simply, as stated, will simply apply the file I've just shown you on my screen. So before doing this, we need to check that our tool for interacting with Kubernetes, which is called kubectl, is correctly working with our cluster. So we can just issue the following command: kubectl get nodes. And we should see here that there is only one node, which is called the MiniCube, and this node should be ready for executing commands. Okay, so that's what we should be seeing. We could also list running containers, get pods -n moon. Let me first of all delete everything. Sorry, I forgot to delete the previous installation. kubectl delete -f. I will just delete everything I had here previously, so we could start from a clean environment. So we'll just remove this. You don't need to do these commands. This is just a cleanup step on my side. It's a bit slow because of the video streaming. Okay, so now everything is deleted. If we issue this command to list running containers, there is nothing running right now. So having a kubectl connected to our MiniCube cluster, we just need to issue one command. We just can copy paste this command, or if we are using a raw kubectl, we can just use a shorter command, because this expression MiniCube kubectl means that MiniCube will find a kubectl binary and call this command. It will just do this. It will just do MiniCube apply -f. So we just can issue this command. And now, after issuing the simple command, everything should be installing on your machine. You can easily check that something is being installed by issuing kubectl get pods -n moon. So after some time, you will have the following state. You will have two pods or containers of pods correctly in Kubernetes terms in state running. And that's in fact everything you need to do in order to start Moon Kubernetes cluster. That's it. The only thing we need to do now to check that everything is running, we need to deliver network connectivity. And there are several ways of doing this. One of the ways is like this: you need to patch respective Moon service. But I think an easier way delivered by the MiniCube is using the following command: this MiniCube command called MiniCube tunnel. So if we run the MiniCube tunnel, it will say that our tunnel is running, and having the tunnel running, we can simply open everything on the local host. So for example, to open the Moon user interface, we can simply open the local host 8080. Okay. Yeah. So you should see the following screen. Command not found, kubectl. Okay. Just to help for those who don't have kubectl, you can download the respective binary from the GitHub too. GitHub.com Kubernetes. No, kubectl install. There are detailed installation instructions in the Kubernetes documentation. So just let me help you to install Kubernetes. Okay, and here in documentation there are several ways. So for example, for Linux, you can just download the binary in the same way I was showing at the beginning. For macOS, there should be a homebrew command. So there are several ways. Just take a look if you don't have kubectl right now. Okay. So we now have a copy of Moon running on our local machine, and let's now start how to say showing what Moon can do for you. So the first thing we are going to do, we just started Moon. The first thing we will be trying is everything related to Selenium features. So in Selenium world, with browser automation, there are two separate types of testing. The first one is manual testing. There are situations when you may need to quickly open a desired browser version and just quickly test something manually in this browser. So for example, let's first of all start a manual session with the latest Chrome version. That's Chrome 88. You can just type 88. Chrome 88. We just go to capabilities, tab. We choose a browser version here and we click on create session. And we are waiting for some time. So if you're having a completely clean Moon installation, starting the session for the first time can take some time just because it's downloading an image from the Docker Hub. So for example, if you now, just let me show you, if you now take a look at the pods in the Moon namespace, you will see that there is a third pod with a respective browser version that we requested. And in your case, it can take some time, for example, a minute or so, before it goes to the running state. So once this pod goes to the running state, you should see a session here. You should see a session here. So here is Something strange. Let me try one more time. Something is not working. Let me try one more time. It seems that this is because of the video streaming. So I'm selecting a browser version. I'm clicking on create session. And I'm just waiting for a new session to create. Just seems to be a bit slow. On your machine should be faster, I think. Let's take a look. Install. Okay, can you go back and show how you got that screen to come up? You just need to go to HTTP localhost 88 and issue MiniCube download before MiniCube download before. So these are the prerequisites to opening the user interface. Whew, there's something strange. Okay, it's working. It's really, really slow just because of the streaming. So after some time, when you click on the create session button, you will see here a new session created manually, and we can now go full screen. We can now unlock the interaction with the browser, and here we can do anything we can do with the real browser, because this is a real browser running in a container in a Kubernetes cluster. So for example, we can open some web page, like we can open google.com, for example. Just open the page. Sorry, it's a bit slow, as I said. Yeah, you can see that this is Google. Let's try to open something else. So for example, let me click I'm not a robot. Oh, fire hydrant. Okay, let me open more tolerant duck go.com. Just this is also a search engine that shouldn't be asking such silly questions about whether I'm a robot or not. So for example here, that's one of the pages you would like to test, and with this manual testing, you could, for example, open the developer tools in browser. You can maximize the screen, and having the developer tools here, we will now be able to do just the same stuff as we are doing with the real local browser. So we can inspect the elements here. We can we can inspect elements. We can browse network traffic that's happening on the page, and so on and so forth. So everything you can do with the real browser, you can do with this browser running in a container. Okay, so that was the manual session. And after you finish working with this manual browser, you can simply click on delete, and it should delete this browser. So that was the first thing I would like to show you here. This is the manual testing. Now I will be showing you the automated testing And as I said, I'm a Java and Golang developer, but however, we are on a JavaScript conference, so I prepared an open source project with WebDriver IO that I will be using for demonstration. So let me send a URL with this project. This is called Moon WebDriver IO example. Yeah, I see that stuff works. Well, guys, so let me answer some questions. Is this view made with VNC? Yes, it's made with VNC. I missed how you start interactive. You need to go to this page, capabilities. You need to select browser version and click on the create session button. There's a blue round button with a lock. Okay, so an example of GS test. So this is an example of GS test I will be using for this demonstration, and that's a really basic test. So I have already my IDE with this test, and let me show you what's inside the test. So here, what I'm having a standard Node.js project with a package JSON. For developers, as dependencies, I have just a WebDriver IO and several related packages. I have Mocha for assertions and Chai. I think I don't know which one is being used for assertions and which one is being used for. I'm not really specialist here. And we also have a standard WebDriver IO configuration file here. So far as our Selenium cluster is running on the local host, we'll be using local host as a host name. We'll be using the standard Selenium port 4444. Path will be also standard, like for Selenium Grid /wd/hub. And this project will be executing one test in a TestJS file. This test is really straightforward. It's opening the DuckDuckGo page. I have just shown you. It's getting the title of the page. It's saving the page screenshot, and it's doing an assertion that the browser the page title in the browser equals to some value. That's the test I will be running right now. And the only thing I need to check, just to not wait for images to download, is that I'm using a correct browser. So here I have so-called Selenium capabilities. That means key value pairs describing what kind of browser I would like to have. The most important things I need to have here is the browser name, which is Chrome, the browser version, which is 88, and I also need this stuff called enable VNC. That means that we would like to show the VNC screen, like I have just shown you in the manual session, and this feature I will use it to debug just to show you how you could debug your test in a local Kubernetes cluster. So in the README file here, it stated that you need to run npm run test, but I don't know how to debug this stuff from the command line, so I will be using my IDE. Here I have a breakpoint, and what I will be doing, I will just run my test in debug mode, and I will simply switch to the user interface and see what happens. So I'm running my test. So we should now reach this breakpoint. Okay. We're just waiting for the session to start. It's a bit slow because of the streaming. Usually sessions should start in several seconds, like 2-3 seconds, maximum 10 seconds. Okay, we now have a browser session and we are now navigating to respective page, to duckduckgo.com. Once this is done, we will reach this breakpoint. Okay, we now reached the breakpoint and we can do just the same thing we did on the previous step. So we can go to the sessions page, which is called stats, and we can just simply click on this button. We are seeing that there is one browser session running, Chrome 88, and we can just click on the session and we are seeing our current test execution state. So we have DuckDuckGo page already loaded by our test here. We certainly can click one more time on this violet button and try to intercept test execution, or in this case, we can simply continue going step by step, and this is how we can debug our test. Okay. So you can use this feature of VNC for both cases, for running manual sessions as well as for debugging your existing tests step by step. So just continue test execution, and we will now certainly get a screenshot here. So that's the screenshot. That's the screenshot. So that was an example of how we could use the same solution for running automated Selenium tests. Okay, let's take a look at the questions. While did you supply mobile capabilities in there? I will show you a bit later. That's the next step. So I will show you this right now. How do I say? What's the difference between workshop and webinar? I don't know. I don't know what's the difference. Usually I prefer the offline workshops. Okay. I will now show you everything related to mobile emulation. First of all, before I show this, let me first of all explain you what I will be talking about. So let me show you several slides. Okay. So I think first of all you would agree that mobile we are now living in a mobile first world, and currently it's very important to test under mobile devices. And historically, testing for mobile devices began with so-called device farms. That means that people were purchasing like dozens of different mobile device models and were doing all the testing. They were opening the web application in every mobile phone model and just testing manually that everything works correctly in each model. Certainly, after some time, solutions like Appium appeared, and people started building their own device farms. That means that they were purchasing USB hubs, they were connecting mobile phones with USB cables to the hubs, and they were just executing their automated tests on the real devices. Uh, this straightforward solution called mobile device farm has a lot of disadvantages. The most important one is that the maintenance cost of such device farm is like too big, because it's too expensive to maintain such farm, because first of all, from time to time, you will need to replace the batteries on these devices because they have a limited number of recharging cycles. You will need to manually confirm software updates. From time to time, your devices will log out from Google Play services or Apple services, and so on and so forth. So in case of having several dozens of devices, you will probably need a dedicated engineer to maintain such farm. So it's too expensive. So the next stage, next step in mobile testing infrastructure were so-called mobile emulators. So, for example, for Mac device, for Apple devices like iPhones or iPads, you have so-called iOS simulators shown on the slide, and for Android devices, there is an Android emulator. These emulators are, in fact, real desktop applications that are showing you just the same screen that a real device does, and they allow you to do just the same things that you are doing with a regular or the real device. However, so these mobile emulators, they allow to easily scale test execution, and the main problem with them that they have rather strict requirements for the hardware. So, for example, these iOS simulators require real Apple hardware to run them. So you need to purchase, for example, Mac Mini devices or even Mac Pro devices, because according to the license, you are allowed to run these simulators only under Apple OS. I mean Mac OS. And in case of Android emulators, the problem is that these emulators are in fact using virtualization technologies. So an Android emulator is a virtual machine. And because of that, you can only run such emulators on real hardware servers or a particular type of virtual machines with the nested virtualization enabled. So this is not so frequent. And because of that, there is a third way that you could use to find a lot of bugs in your web applications. This is so-called mobile emulation, because our goal while we are building the browser automation infrastructure is not building the infrastructure. Our goal is finding bugs. And our experience shows that you can catch 80 or even 90% of bugs by using this mobile emulation. So those of you who have already who are using Chrome could probably see the following feature of the Chrome developer tools. You can easily emulate different devices just by selecting them from the list. So here, for example, there is iPhone X, iPhone 10, and um, in fact, this mobile emulation works by changing the viewport of the browser and by adding the respective user agent HTTP header to every request. And such a simple approach allows you to catch a lot of bugs. So let's now take a look at how this feature works with Moon. So let's simply return to my test and take a look at the capabilities we have here. So here we have a set of additional capabilities related to mobile. We have a key mobile device, and we have two values. The first one is device name. The second one is device orientation. So device name corresponds to the device model we would like to emulate. The orientation corresponds to the device orientation. That means whether we need a portrait or landscape orientation of the device. So the only thing we need to change here in order to start the mobile emulation, we need to change the URL for a Selenium session. We need to replace the path wd/hub with just mobile. So there is a note here about it. Okay, so we do this modification, and I will simply rerun my test in debug mode, and we will see what happens. So I'm rerunning my test and wait for this breakpoint to activate. So the session is being started. we are opening the page, and we will see the difference in the user interface. So now I have the following in my user interface. I have, first of all, the note that we are currently using the mobile emulation mode. So here is the device name, and the fact that this device is running in the landscape mode. And if I click on the button, I'm seeing that we are having something very similar to the screen of the real device. So we can see that we have something, yeah, very similar to the screen of an iPhone in the landscape orientation. So and certainly, if we continue, we remove the screenshot, and if we now, I remove the screenshot. Sorry. So let me just rerun the test and show you the screenshot. Just will do this one more time. Here is the screenshot. Here is the screenshot. I can stop this. You can see that on the screenshot that we have exactly the same stuff. So we have stuff very similar to real mobile device. And the main difference of this solution compared to Android, to emulators or mobile device farms is that, first of all, it allows you to catch a lot of bugs, 80 or 90% of bugs related to mobile version of your application. And the main advantage is that this will work as fast as the desktop browser, because real devices and mobile emulators are known to be fast and are known to consume 2 times more CPUs and memory compared to desktop browsers. So that was everything related to mobile emulation. So let's take a look at the questions now. Okay, people are solving the issues. Nothing per state. Okay, I see that guys somehow resolved this feature, this issue. How to make this run in multiple sessions at once? You just need to run several tests in parallel. I mean, I'm not really an expert in running JavaScript tests in parallel. I will be showing a bit later today how to run like 50 tests in parallel. I will use my Golang code just because I have more experience with it. But I think you should be able just to click several times, or probably you could somehow fork Node.js processes to run several tests. So I'm not an expert. Probably WebDriver.io can do this. There should be, yeah, probably this one max instances parameter should do this. I'm really not an expert. I increased the max instances to 4. I don't know. I'm not an expert. Okay, so let's continue. The last thing I will be showing in the first part is everything related to Playwright and Puppeteer test execution. So before we dive into the real example, let me explain what is Playwright, what is Puppeteer, or what is the motivation behind these tools. Okay, so let me show you several more slides. So how would I say? The first fact is that Selenium, as a currently worldwide de facto standard of browser automation, appeared in 2004. That means right now it has already 17 years. And it was created in the times when the majority of websites consisted of a lot of HTML with the small inclusions of JavaScript, and the majority of the websites were how to say, generated or rendered on the server side, for example, with the PHP code. Currently, we are in 2021, and we are living the world of the single-page web applications, where half of the entire web application logic is living on the client side. These applications are executing a lot of JavaScript code. They are doing a lot of, how do I say, network requests in the background, for example, using Ajax, and so on and so forth. And the problem with this regular Selenium is that regular Selenium just is missing some features that are important for testing modern web applications. So for example, a standard Selenium simply can't list the network requests. So you can just watch what your web application is doing on the client side. You can directly manipulate the DOM tree and the CSS styles. You can subscribe to the JavaScript events happening in the browser, and so on and so forth. And such considerations, such a lack of features, just lead to how to say lead software engineers, just not lead, that made software engineers. They just created several new solutions, and I think most of you have already seen this panel. This is the Chrome Developer Toolbar, and all the features missing in Selenium I was talking before are already present in this toolbar. So you can inspect the elements, you can sniff the network traffic, and so on and so forth. And this Chrome Developer Toolbar behind the scenes is using a so-called Chrome Developer Tools protocol to interact with the Chrome browser. So when you're clicking on a button in the toolbar, this toolbar is sending a request using this protocol to the browser. And knowing this, a very simple idea comes to the mind of an engineer. Instead of doing all this stuff manually by clicking on the button, you can just implement a library that will be doing the same stuff with the code. And so this idea that was the main idea for creating the following tools. The first one is called the Puppeteer. This tool is created by Google, and initially that was the first known client library for this Chrome Developer Tools protocol. So initially, Puppeteer was able to work only with Chromium-based browsers like Chrome, Opera, and so on. But currently, Puppeteer also has experimental support for Firefox browser, and it seems that in the next releases of Firefox, there will be a stable version of this Chrome Developer Tools protocol support. So that's the first one. The second tool that appeared approximately a year ago is called the Playwright. That's a product from Microsoft, and I know that it's being developed almost by the same team that initially created Puppeteer. And Playwright initially was a Node.js library like Puppeteer. That was a library allowing you to test in one of three possible browsers, in three possible, like, not browsers, like engines. The first one is the Chromium engine called Blink. The second one is the Firefox engine called Gecko. And the third one is the engine being used in Apple browser, Safari and Safari Mobile. This is called WebKit. So Playwright main idea is that if you are able to test in these three rendering engines, they are work the same way on all platforms, and because of that, this should be sufficient for testing the majority of the web applications. Because currently, 90% of modern browsers are using one of these three engines. And Playwright, compared to Puppeteer, is not only a Node.js library. There are also versions for Python, Java, C#, and probably several other languages. So knowing this, let me now show you how it works with the same cluster. So let me do this. me do this. Let me first of all create a directory for Puppeteer test. We switch to this directory, and we will first of all install this library. So this is usually done with a standard npm command, npm install Puppeteer core. So let me explain why we're using Puppeteer core. So if we go to npm.js, we're going to go to npm.js.com. We are typing Puppeteer here, and we will see that there are two different packages. The first one is called Puppeteer. The second one is called Puppeteer Core. So both are managed by Google. The main difference between these two packages is that when you are using just Puppeteer, you will also be downloading the binaries with the Chrome binary needed for running Puppeteer tests locally. But so far as we're using containers running in Kubernetes cluster, we need to download Puppeteer core. So this is just the same version of Puppeteer, but only the library itself without the binaries. And if we take a look at the versions, we will note that every version of Puppeteer is also tagged by the browser version. So let's, for example, take the version compatible with Chrome 86. These additional tags are needed because the protocol between the browser and the library changes from one browser version to another. And because of that, you need to update the library version accordingly. So let's use Puppeteer core for Chrome 86. Puppeteer core at Chrome 86. So we're now installing this library. And after doing this, we will try to launch a very simple test. Okay. So here is Puppeteer installed. Now let's try to launch a very simple test. Let me open the documentation, MiniCube.com. So let me just type the command npm install Puppeteer core Chrome 86. So let me show you. You can either take a standard test from Puppeteer example, or you can take from our documentation. So we just go to the documentation. We just go to the respective section related to Puppeteer. Let me show you. And let me copy this. Puppeteer test example. So I will just copy this test. I will create a new file with this test, insert this example, and the only change I want to do here, I will need to replace the host where I will be requesting the browsers. So I'm replacing this to localhost. And here I will also need to request Chrome 86. So Puppeteer, compared to Selenium, has no capabilities, has no capabilities at all. And because of that, if you wish to request different browser versions, you need to pass all such information in the URL you are using for requesting the browsers. So this Puppeteer test is doing just the same thing we were previously doing with Selenium. Let's, for just simplicity, use the same page, for example, duckduckgo.com. Let's open this page and let's take the screenshot. We'll also print the page title here. So now I run the test, node index.js. And it should now start a browser pod in the same way it was done with, the same way it was done with Selenium. So there should be a browser pod running here. Here is the browser pod, which is already terminating. And we can see that here is the page title. And I can also open the screenshot that was taken with the Puppeteer, that the same screenshot of the DuckDuckGo web page. So here's how Puppeteer works. Now let's do the same with Playwright. So we create a directory for Playwright test. We switch to this directory. With the Playwright, we have the same issue as with Puppeteer. By default, Playwright, by default, Playwright tries to download the binaries for local test execution. But so far as we'll be using everything, we'll be running everything in containers, I will just cheat a bit and take a command from the history. So I need to do the standard npm install playwright, but in order to not download all the browsers, I need to add one more environment variable here. Let me just copy paste this command. Yep. Do we do it in empty directory? Yes. How come the sample script didn't run the test from local browser, but the Moon pod is used instead? Let me explain before we start running the Playwright test why. Let's go again. Let me open the Puppeteer test, index.js, and explain why we are using the remote browser. So compared to a standard Puppeteer test, here instead of Puppeteer launch, we have Puppeteer connect. And here there's an endpoint. So here we are specifying that we're connecting to a WebSocket on the local host port 4444. And for every such connection, so far as we're using the WebSockets, Moon is creating a browser pod, considering the parameters you are passing in the URL. So here, for example, you can also add parameters, for example, for activating video recording, for enabling using headless or headful browser, and so on and so forth. So all this stuff is described in documentation, but we have no time just to show it. So continuing with the Playwright, let me just install the Playwright. I will just install the library. As usually. And while it's installing, I will do the same stuff as with Puppeteer. I will go to just take an example here. So I will just copy paste the code. It's really very similar to Puppeteer, just because one framework is a fork. Puppeteer initially was a fork of Playwright was initially a fork of Puppeteer. Sorry, like this. So we insert an example code, and in this example we will be using Firefox. So for example, let's replace our connection host to localhost. Let's again replace the page URL to duckduckgo.com. And this test is doing just the same thing. It's opening the page and taking a screenshot, and that's it. So we can see that here we only have the test itself, the node modules, and the package log.json. So we run the test, and we will now see that it's also taking a screenshot in Firefox. So as usually, we can see that here is a pod with Firefox being run. It's already running, and that means that our test will soon finish. So it finished. And we can open the screenshot now. So that's the screenshot in Firefox. You can see at DuckDuckGo to Firefox. So it works like a charm using the same tool. That's everything I wanted to show you in the first part. Let's now have a question and answer section. So let me take a look at the Discord channel. So I already answered how come the sample script didn't run the test from local browser. That's headless would be nice. Headless is already supported. So by default, browsers are running in headless mode, I think. Moon is exposing port 4444 for the pods. It's exposing port 4444 for commands. For example, you request a browser session using one of the frameworks, Selenium, Puppeteer, and Playwright, using the same port. However, in case of installing to a cloud, for example, you could hide this port. You can just have a regular domain name for the browser pods. Where will be the recording of the session be available? I think Lera will answer. So don't hesitate to ask any questions. Just I will try to answer. Let me try to find a question from Vadim. I started the timer, but still have nothing via localhost port 8080. I would say if localhost 8080 doesn't work in your case, you could try this second approach described here. You could try to patch to execute this command. So you could try to do this. How is Puppeteer and Playwright able to connect via the DevTools protocol remotely? So Puppeteer and Playwright are able to connect to the DevTools just because they are able to connect to a WebSocket. Internally, they are using a WebSocket to send and receive respective commands. And so far as Moon is proxying this WebSocket from from port 4444 to the pod running inside the Kubernetes cluster, all this stuff works. How can I ensure my test suite always running the latest version on the market? I would say regarding this question related to the latest browser version, I would say that first of all, we are building the respective browser images immediately when the stable browser releases appear. But however, you can also build an image yourself if you wish. And basically, we do not recommend always using the latest browser version. We recommend using an exact browser version in capabilities or in in the URL in Puppeteer or Playwright. just because otherwise, if you are relying on the latest browser version, your tests can start failing sooner or later if something changes in the browser. Just to help Vadim, contact me. Oh, sorry. Just for those who are having any personal questions, you can contact me in Telegram if you wish. Okay, I think we will now have a break of 5 minutes. And after the break, in 35, we will continue, and I will show you how to install the same solution to a cloud platform. Okay, so you can now go and prepare some coffee.